Hi, this is the second part now of the 2014 June Higher Maths Paper 1 Solutions. Okay, second video, starting from question 5. Okay, we've got two pie charts here. This is more of a numeracy question. But okay, this is the olden days, it was all chucked in together. Okay, there are more pupils in class B than class A, so the second pie chart is bigger. That's not a standard thing. That's just to help you out. Okay. There are 4 boys in class A, so what I would say is, as you get given information, label it. There are 4 boys in class A. Well, we can work out then how many girls there are, because each quarter of this pie chart is worth 4. So there must be 4 there, 4 there, and 4 there. So there must be 12 girls in this class. Okay. There are 1.5 times as many girls in class B. So we need to times by 1.5. Well, times by 1.5, you can times by 1, and find a half and add them together. So 1.5 times 12 is basically 12 add 6. So there must be 18 girls in class B. Okay. Now this is where you'll need to get your protractor out. It's a nice fraction, you may be able to guess, but just to be on the safe side, if you get your protractor out, what you'll find is that this is 120 degrees, and therefore this is 240 degrees. When it comes to pie charts, you need to spot common angles. 120 degrees on a pie chart is 1/3 of a circle, and 240 degrees, common sense would tell you then that must be 2/3. So 2/3 of the class are girls, and 1/3 of the class is boys. There are twice as many girls as boys. Okay, 240 degrees is 18, so 120 degrees must be 9. There are 9 boys in class B, and the marks, the 4 marks, are for various calculations. So spotting the 12 gets you a mark, getting the 18 gets you a mark, and then doing this angle measure and realising that it's doubling and halving, and there are 9 boys. That's the last 2 marks. Okay, so easy enough really, as long as you're comfortable working with pie charts. Okay, question 6. At this point, you see, I'm glad to see a nice page of algebra. We know what to do in algebra. Okay, we've got an equation with x's and numbers both sides. We want to try and get the x's one side and the numbers on the other. So what I'm going to do, look, I'm going to take that 4x over to that side, because I'd rather do 6x take away 4x than the other way round, so I don't want to go negative. And then I'll move this minus 27 the other way, and I'll go to a plus 27 on the other side. Okay, so that equals minus 13, which was there already, plus 27. All you've got to do now is tidy it up and solve it. So on the left hand side, we're left with 2x. On the right hand side, minus 13 add 27 is 14, divided by 2, x is 7, easy 3 marks. Okay, part B, x over 2 add 18 equals 26. Okay, the add 18 is not part of the fraction, so the fraction was done first, it was divided first, and then the adding. So if we're going to work back to front, we'll need to take the plus 18 over. It'd be different if the plus 18 was part of the fraction, but it's not. So that goes to a minus 18. So we've got x over 2 equals 26, take away 18. So that means that x over 2 equals 8. And then if we want to get rid of this divide by 2, it becomes a times by 2 on the other side. So x equals 16, and we can check that. 16 divided by 2 is 8. 8 add 18 is 26. Factorise means put into brackets. I mean, we're still early in the paper here. This is single brackets. Okay, there's only 2 terms, not 3, so it's not like a big quadratic where you've got to find the pairs. It's easier than that. Look at what they've got in common. There's no number they've got in common, but they both have a y, so y goes outside. And then if we divide by y, that's not going to be squared anymore. That's just going to be plain old y, and that y is going to go as well, so that's just going to be a minus 5. That's easy. Okay, expanding is the opposite, multiplying it out. Y times y squared, y times y times y cubed, and y times plus 4 is plus 4y, a mark for each 2. Nice, easy. I love the algebra page, especially the early one. Then inequality. Now people panic when they see an inequality. I don't know why. Just pretend it's an equals. I know it's not, but you can pretend it is until we get to the end. Just work through, do the opposite. That minus 6, that goes to the other side and becomes a plus 6. Okay, so 30 plus 6 is 36. Now we're not equal to that, we're less than that. Doesn't really mean a lot in this question, but it is. And then we want to divide by 5. Now, 36 divided by 5 is not particularly great, and it's very unusual that it will be a nice divide in here. Okay, they quite often come up not great. You can leave it like that, and you'll get all the marks. Okay, you'll get 2 out of 2. You could write it as a mixed number. How many times does 5 go into 36? It goes in 7 times, remainder 1. So you could write it as 7 1/5. And now you know it's 7 1/5, you could even write it as 7.2. Okay, but you don't need to do any of that. You can leave it on this question as 36 over 5, that's not a problem. If it asked us for the greatest integer that satisfied the inequality, what is the biggest whole number we would be allowed? The answer would be 7, because that's the biggest whole number. Integer is a whole number that's smaller than 7 1/5. But for this question, we're done. Okay, on to question 7. We've got a pattern made of blacks and whites, but we're looking at them separately. Okay, we're looking at the black circles first. Now, they've drawn it. Why do you think they've drawn it? It's to help you see what's going on. Not obvious there, but hopefully getting more obvious as I do this. They are actually making a square, and if you count them, we've got 1, then 4, then 9. Hopefully you recognise those as the square numbers. So how many would be in pattern 4? It would be 16, because it would be a square that's 4 by 4. How many in pattern 5? There would be 25. So how many would there be in pattern n? Well, if this is 1 times 1, 1 squared, and this is 2 times 2, which is 2 squared, and this is 3 times 3, which is 3 squared, well, in pattern n, it would be n times n, n squared. Okay, all you do is take the pattern number and square it. Okay. For the white circles, it might be easier here to actually write down how many there are. So we've got 3, then we've got 5, and then we've got 7. And straight away I notice that's a linear sequence, as in it goes up by the same amount every time. It goes 3, then 5, then 7. The gap is 2. It's a linear sequence. If you've got a linear sequence going up in 2s, then we know that 2n must be in there somewhere, because this sequence is based on the 2 times table. It's not the 2 times table because it starts on 3. We need to add 1 as well. Okay, 2, 4, 6, add 1 becomes 3, 5, 7, so 2n plus 1. And then you can do all sorts of things after that. If it asks us to work out how many black ones were in pattern 10, the black ones would be 10 squared 100. If it asks us to work out how many white ones were in pattern 10, it would be 2 times 10, add 1, 21. Okay, number 8. Never very nice, where you've got to write your own expression. So what I would say maybe to get you started is pick some angles and just see what happens if you're not sure where to start. This is obviously Z, C and F angles, you can tell by the parallel lines. So what I'm going to do, I'm going to pretend that that is 60 degrees, and I'm going to pretend that this one is very small, it's only 20 degrees. And we'll work it through with numbers and we'll see what happens. And we're trying to work out the size of angle C, which is down there. Okay, well I know then that's 60 degrees because it's opposite. Okay, I can work out that here must be 120 degrees because angles on a straight line make 180, and that must be 120 degrees as well. There's lots of letters here, but if I say that there's a letter Z there, look, between angles, then basically I can say, well, if that's 60 degrees, then so is that. And we repeat. all of our angles from the first part. 20 and 120. Now I can work out this angle here. Now 20 and 60 is 80. That leaves me with 100. And I can work out that the opposite to that is also 100. To work out angle C from where I am at the minute, probably the easiest way to do that, let me pick a colour, is to use the rule for C angles. Oops, there we go. And the rule here is that they add up to 180. So this angle must be 80 degrees. Well, why is that significant? Well, the numbers I started with was 60 and 20, and the angle I ended up with was 80. That's not a fluke. If you try this with any numbers, you'll find that this angle here is always the sum of what you started with, A and B. Test it out with some different numbers if you want, but you'll always get those two added up. So C is actually just equal to A plus B. It looks so easy when you're finished, but not quite as easy when you're doing it. Okay? If you wanted to do this in actual algebra, okay, so that angle there would be B. That angle there, I'm going to have to write a little bit of algebra here. It's 180, take away A plus B. You'd add them together and take away from 180. And then, so is that angle there the same. This is why I prefer to do it in numbers, especially if you can get a definite sort of a pattern going. How did we find that one? Well, we took this whole angle, all of this got taken away from 180, so you end up with this rather strange looking thing here. 180 take away 180 minus A plus B in brackets, and that's all one thing as well. And what happens is, look, they cancel out. That minus and that minus become a plus, and what do you get left with? You get left with A plus B. That's quite tricky to do with algebra, okay, especially with the cancelling out here. So if you're ever unsure, and circle theorems is another one where this sort of maths comes up. If you're not sure, put some numbers in and work it through in numbers. At least then it'll give you a bit of a clue of what to do with the letters if you don't spot it straight away. Okay. Right, we're not going to get this question done in my 15-minute slot. So what I'll do is I'll stop this video and I'll start question 9 on a brand new video. This is quite a big question.